Hello everyone, and welcome to our big launch event. Before we look at the impossible, I want to thank each and every one of you, wherever you are in the world, for being with us in this incredible historical moment.
For close to 25 years, SLM Solutions has been pushing the limits of what's possible in the world of selective laser melting technology. Selective laser melting does not only define the company name, but it's commonly used around the world to describe the application of metal additive manufacturing as a whole. In 2006, SLM Solutions was the first company to successfully process aluminium and titanium with selective laser melting technology. In 2013, SLM Solutions released the SLM 500. With its multi-laser technology and automated powder handling, it became the flagship system for high-volume metal additive manufacturing. SLM Solutions' continuous contributions to metal 3D printing technology make them the leading name in additive manufacturing around the globe. And today, it will do it again.
I've been waiting in anticipation for this moment for quite a while. I've had an exciting career in the industrial sector, and I've seen some cool stuff. But today is an absolute highlight, because what I'm about to share with you is something amazing and out of this world. So, we are launching a machine that would not only bring SLM Solution to a different level, but change manufacturing as a whole. I can proudly say we are really pushing the limits here. Today, SLM Solution has over 700 installed machines operating all over the world and in all market sectors. And while they are able to produce great things that only a few years ago were unthinkable, today we are launching a machine of a new technology series. We have been developing this technology for years, and now we have matured the product and ready for production. I'm excited that finally we can share this moment with you. So once again, thank you for being here. Now, I would like you to meet our boldest and game-changing machine to date, the NXG 12600. Let there be lasers.
The NXG 12600 is a revolution in industrial manufacturing. Up until now, the limit had been considered to be that of a quad laser system. What we have here is not a single nor a quad laser system, but a machine with 12 lasers. And it's here, it's ready now for serial production. Make no mistake about it, this is the first machine of its kind. When designing this machine, we focused around 4 key principles: productivity, size, reliability, and of course safety. And I'm unbelievably proud of what we've achieved. This is truly the dawn of a new era in manufacturing.
A technical revolution is only possible with exceptionally talented team. I'm extremely proud to hand over to our experts to dive deeper in the capabilities of the NXG 12600.
Initially, customers had asked us to create a machine with a larger build platform. In further conversations with customers, we then figured out that a larger build platform alone isn't sufficient. You also need a higher build-up rate, because customers don't want to wait 3 weeks until the part comes out of the machine.
We had to maintain our focus on CTQs such as affordability, maintainability, serviceability, and time to market.
Now, moving into production of very large parts, the question came up whether or not to compromise on quality, but this was never an option for us. When printing large parts, the expectation is to reach the same high level of quality and precision as known from our current generation of SLM machines.
The cost per part produced can be reduced by increasing the productivity of the machine.
With our next-gen machine, we were aiming for a product revolution, a true step change in technology.
So the goal we set was to achieve a step change in productivity, not only a gradual improvement.
The NXG-12-600 is more than 20 times faster than a standard single laser machine. It's also 5 times faster than our quad laser machine, which, by the way, is already the fastest machine in the market.
By adding more laser sources and higher laser power into the system and shaping the process condition to the required part quality level, we are able to significantly reduce cost per parts.
The NXG-12-600 is ready even faster to build your application with 12 lasers.
A machine with 12 kilowatts of installed laser power would not help if you don't properly manage the metal condensate from the process, the thermal load and the way the 12 lasers work together.
The NXG-12-600 comes with significantly reduced laser off times compared to our existing powder bed fusion machines. We achieved this by decreasing the skywriting time by half, doubling the jump speed and reducing the fire-to-fire time by up to 40%, means a reduction of the laser off time between 2 layers. Customers can rely on the patented bidirectional recoating, which has been redesigned to be more compact and gas flow optimized. One core element of this machine is our patent-pending scan field partitioning strategy. To achieve maximum productivity, it is necessary to distribute the total laser workload equally to all lasers, while at the same time minimizing laser interaction. This enables customers to make full advantage of all 12 lasers.
The potential cost reduction in production that this machine offers you means for the first time in the history of additive manufacturing that you can have true serial production and integrate fully into your supply chain. This immediately takes your manufacturing operations to a new level. The potential here is tremendous.
Here you can see the process chamber. It has a full build size of 600 by 600 millimeters.
It's the biggest build envelope we've ever put on the market, and that's for a good reason.
The build envelope combined with speed generates an output which is unparalleled in the market. The part output of a single machine can exceed 10,000 kilograms of produced parts per year.
This size enables the customer to print very big parts in a short time.
In fact, the build envelope size is optimized for large parts in the aerospace and automotive industry and high volume productions.
Our main goal was to get really 12 lasers working simultaneously in a build area of 600 by 600 square millimeters. To achieve this, we even developed our own scanning units, which are designed to perfectly fit this build area and which are of an extreme compactness. We now even have a tailored laser focus size. We call it zoom function. This obviously allows to get high laser power into the powder bed, and this helps to push productivity.
To maintain and even enhance the quality of the powder bed fusion process, the NXG-12-600 features a robust machine design boasting a new thermal concept. This reduces thermal drifts to a minimum and allows customers to print seamless parts stitched together with up to 12 lasers. Due to the nature of the powder bed fusion process, using up to 12 kilowatts of laser power means that a huge amount of it would be reflected from the powder bed onto the surrounding process chamber.
As you can imagine, up to 12 kilowatts of laser power challenge the temperature management of the complete machine.
Achieving a constant temperature of the key components is crucial for high-quality build. As a result, we built a robust machine designed for a stable positioning of the key components and integrated a new coating concept of the inner process chamber. Adding to this, we are also able to maintain a constant substrate plate temperature independent of the laser power input.
We successfully extended the cooling concept to the optical modules.
The gas flow in the process chamber and how to arrange the 12 scanners in combination with that gas flow is one of the most important aspects when designing such a highly productive machine.
The 12 lasers within the NXG 12600 machine produce a lot of metal plume and spatters. The interaction of these so-called process byproducts with laser radiation can lead to defects within the final part. In order to avoid these defects, shielding gas flow is used to remove the process byproducts from the build chamber. Given the size of the chamber and the amount of lasers used, the design of a proper shielding gas flow was a major challenge. We tackled this challenge using CFD simulations along with extensive flow measurements. The outcome of this are specially designed flow in and outlets along with a chamber design optimized for a proper gas flow. This, along with our proven and patented sintered wall technology, ensures a proper gas flow throughout the whole chamber.
With the optimized gas flow setup in the NXG 12600, we achieve homogeneous part properties all over the building platform. The zoom functionality of the optical system opens new possibilities in the parameter development. The non-productive times can be reduced significantly due to the variable beam diameter and the available laser power of up to 1000 watts for each laser. With an increased beam diameter, an increased hedge distance of up to 400 micrometers is possible, leading to less vectors and therefore less turnarounds. For contour accuracy, beam diameters of 80 micrometers and, for example, 160 micrometers can be combined in one layer. Up to now, it was not possible to build parts out of nickel-based alloys or steels with a laser power with more than 350 watts. Also here, the zoom functionality enables to use an increased laser power of up to 800 watts. In these material groups, we expect a larger jump regarding the build-up rates in comparison to aluminum, where we already achieved very high build-up rates in the past. Also for aluminum alloys, we expect higher build-up rates, especially through the use of 12 lasers. Here, theoretical build-up rates of more than 1000 cubic centimeters per hour are possible. Currently, we expect no limitation regarding the material which can be built on the NXG 12600.
We are able to offer you a closed powder system based on two basic principles.
The first option is the gravity-based powder supply solution with two overflow tanks at the bottom and one supply tank on top of the machine. The second option is the vacuum powder supply version. Here you will have a big tank below the machine which is connected to the powder supply and sieving station.
No matter which solution you choose, we implemented a powder buffer above and below the NXG 12600 machine to keep downtime between each build jobs to a minimum.
In both cases, we have an integrated buffer tank of 235 liters. This tank is to ensure the high reliability of the NXG 12600.
During the development of the SLM 800, the question came up, how could we reduce unproductive process steps? By reducing or even preventing supports starting at the base plate up to a height of nearly 800 millimeters. Today we can build short-range overhangs without supports down to an angle of 5 degrees. We can build long-range overhangs of several centimeters down to an angle of 10 degrees.
We strive for industrialization with the additive manufacturing process, and the software is in line with that goal. For the NXG 12600, we improved the productivity of the software tremendously. But productivity comes with usability, so we also focused on usability. We focused on certain user types. Our main focus was, of course, the operator. And we looked at this person and we thought about how can we create the software in a way that the person is safe to use the software, that it is safe to operate the machine, that the person knows what has to be done next, and that it understands the machine easily. We also want to reduce the training time for the operator. So you get the machine and you can operate it immediately. The best thing about our new software is that it does not come as a toolbox where you have to know which tool is where, but we deliver a solution that you can use immediately because it tells you exactly what you need to do.
Now, let's talk about what this machine could do. We have been testing the NXG 12600 for over a year now. In addition to the parts that you have seen at Formnext last year, here's another part that we want to share with you. This is a mid-frame for an application in the aerospace and defense. This part is very complex, very difficult to do with the traditional manufacturing. As you can see, we also tested the material properties. You can see the tensile bars. You can see the details of the complexity of the geometry of the part. The material properties are fantastic. And as an example, the density is over 99.5. Now we're talking about different sector. Here's another part for automotive. This is an engine housing that's made out of aluminum. The part is extremely complex. It's hollow from the inside with lattice structures. The amazing part about this took only 21 hours to build. This would have been almost impossible to make with any other manufacturing processes or any other equipment. The material properties also exceeding our expectations.
Now, the NXG 12600 is ready for our core strategy to work with all lasers on one built part.
We can proudly claim we are the first additive manufacturing company that design and deliver with an industrial mindset. The end result, our successful, functionally, and totally revolutionary product is now on the market.
With the NXG 12600, we're going to production, high volume, serial production, full steam ahead. And that's exactly what this machine was designed to do, from the ground up. With the inclusion of 12 1-kilowatt lasers, this is truly groundbreaking. With the arrival of the NXG 12600, supply chain and inventory models will change forever. Vastly increased volume output at reduced product costs mean this is not just an important day for additive manufacturing, but an important day and a breakthrough for manufacturing in general. To sum it up, what the NXG 12600 offers, nothing on the market comes even close. It is here, it's working, it's not a twinkle in one of our engineers' eyes. This is something that is ready to order now.
To wrap it up, I hope you enjoyed the show. We have unveiled a miracle. The NXG 12600 is a lightning-fast machine, a game changer for our industry and manufacturing as a whole. The machine is ready for commercial offering. All this would have not been possible without the support of our dedicated and talented team, and of course, our valuable customers and partners. Thank you. Thank you for joining us on this exceptional day.